Good afternoon and welcome to this webinar about how to build sustainability into your UHT plant-based processing lines. Just a quick introduction about myself. My name is Serafin Garcia. I work as the technical sales manager for UHT systems and script surface heat exchangers in the EMEA region. So that is Europe, Middle East, and Africa. And I help stakeholders like yourself with thermal applications, including UHT systems, and applications like plant-based, that today would be the main topic. Within that topic, we will be discussing the best ways to save energy, water, and optimize efficiency. So just some housekeeping notes before we start. You will not have audio or video capability, but please use the question and answer feature to submit any questions during the presentation, and I will try to answer them at the end of the presentation. If we don't have enough time, we can continue with one-to-one sessions, as I will be providing my contact details. All right, so thank you very much for joining us today, and let's get started. Just a second to remind you on our purpose, that is to improve the world through innovative and sustainable solutions. This is going to be the agenda for today. So we will be discussing about some basics and UHT systems, and we'll be getting deeper on the energy savings options that we've got within our portfolio of solutions. And then we can finalize the presentation with some information about our innovation centers, our pilot plans, and our performance agreements. So this is an example of a plant-based processing line. In this case, we are talking about oats as the raw material. And it's a typical line from SPX flow. You typically start with the flour, and then you end up with the oat beverage drink at the end of the line. So normally we try to have a conversation with the customer to understand how they want to do things and how we can incorporate some of our experience to improve their processing lines. So if we start looking at the upper part of the slide, you can see that we start with a mixer. It could be one of our flex mixers. So we add the oats in flour form, and then we put it in the tank. We add some water, and we obtain some sort of thick slurry. So then we need to add some enzymes to reduce the viscosity. And we tend to work on batch basis because in that way we can get both the temperature and the enzyme under control. We can heat up with direct steam to the ideal temperature for the enzyme to work. And then we add other type of enzymes and we let it work for a couple of hours for the second type of enzymes to release the natural sweetness of the product. So actually you can put into your label that 0% concentration of sugar has been added. Then we can use a decanter centrifuge from one of our partners to get the fibers out. And in that way we can avoid the sandy texture mouth feeling. And then we can do a further heat treatment, as you can see on the slide on the lower part, where we are showing one of our infusion systems. Okay, so in the plant-based processing, there are several challenges where SPX Flow stands out as a market leader in the UHT technology. And that is the best way that we have to show our commitment to sustainability. In fact, famous plant-based producers are trusting today in SPX Flow as we keep delivering solutions on waste reduction, energy efficiency, and keeping the taste, the flavor, the texture that our customers want without compromising on the food safety part. We have dedicated innovation centers to carry out trials to test on new recipes. And thanks to many years of experience, we can ensure sterile products with minimal nutritional and organoleptic changes. And we can also help customers to create solutions meeting local regulations, the local legislation, and contribute in that way to a greener overall food and beverage industry. In this slide, we can see an example of one of our Infusion Plus systems where we can achieve premium quality products for your plant-based applications. In the infusion technology, we could say that it is very versatile because you can run ESL, that means extended shelf life products, as well as UHT products. And you can do that in the same machinery. Within the Infusion Plus, that I would say it's been the most innovative development that we have seen within the thermal technology for many years. We can achieve really high temperatures, up to 157 degrees, with short holding times, less than 0.1 seconds. So that is actually giving you extremely high quality results in terms of the quality of the product. And also 70% less vitamin loss than other treatments. The Infusion Plus is actually the perfect technology to produce ESL beverages because you get pretty much the same high quality and taste as a normal high temperature, short time procedure, but with the advantage of having a longer shelf life. So we can get up to 45 days if we preserve the beverage in the cold chain at 10 degrees versus a pasteurized product that could have a shelf life of typically a week. So you can see the added benefit in terms of the shelf life. Right, so just a quick definition of UHT for those people that are new to this topic. The UHT process is a food processing technology that we are using to sterilize liquid food products. So essentially what we do is that we heat them to very high temperatures for a short period of time. And the benefits of this process are that you can get an extended shelf life because we can actually get up to a year, depending on the raw material quality. You can also get extended food safety without compromising on the nutritional value. And also, finally, you've got the possibility to increase your business because you don't need the cold chain during the transport and the storage. So that is quite convenient, especially in those countries where the cold chain is not that developed. Just a quick difference between pasteurization and sterilization. In the pasteurization, even though we are eliminating the bacteria, there will be spores that would survive the thermal treatment. So we need the cold chain. And also these products would have a much shorter shelf life. Typically, we are talking about a week or a few days. Sterilization refers to the complete elimination of all microorganisms. And within the food industry, we use the more realistic term of commercial sterilization. So that means that the product is not necessarily free of all microorganisms, but those that are surviving the sterilization process are unlikely to grow when kept in an aseptic container at ambient temperature. Just a quick comment here regarding the ESL. We spoke about ESL before. An ESL product is still a pasteurized product and requires the cold chain. A UHT treated product is sterile and doesn't need the cold chain. And finally, just to finalize this slide, just a reminder on a scientific fact. That is that the speed of reaction by temperature increase is much faster for germ destruction in a factor of 10 to 30, than for chemical reactions in a factor of 2 to 3. So that is what we do in the infusion system. We heat up the product to really high temperatures, and we keep it for like really short holding times. Within the UHT processing, we can differentiate between direct UHT and indirect UHT. So in the direct UHT, we have an actual mix between the steam and the product. And we can further distinguish between infusion and injection. In the infusion, it is the product going into the steam, and in the injection, we've got the steam going into the product. In the indirect UHT systems, there is no mix between the steam and the product. The energy, the heat, is transferred from one fluid to another across a thermally conducting barrier. That could be, for example, the metal walls that you've got in a plate heat exchanger, a tubular heat exchanger, or a scrape surface heat exchanger. This is a generic schematic of one of our infusion plants. So the working philosophy of the plant would be as follows. You've got the product sitting on the balance tank, and that product would be pumped by means of a centrifugal pump into the multi-section plate heat exchanger, where we carried out the preheating in the first section. Then the product goes into the infusion vessel, where by means of the distribution nozzle at the top is introduced and put into contact with the steam, which is in the vessel. During the flow of the product from the nozzle to the bottom of the vessel, the product would reach the target sterilization temperature. After that, the extraction pump sitting below the infusion vessel will push the product into the holding section, and from there directly into the vacuum vessel, where the steam would be flashed off. As a result, the temperature of the product is going to be reduced. After the product would go into the aseptic homogenizer, and then back to the plate heat exchanger, where we can do a final cooling. Finally, the product can directly go into the filling machine if the machine is ready to work, or it could be aseptically stored if we've got a sterile tank available on the factory. In this slide, we can see in a more detail our infusion vessel, which is actually where the magic happens. The vessel is completely full of steam, and by means of our distribution nozzle at the top, that is essentially working as the shower that we have at home, we create many different product streams, obtaining in that way a large heat transfer area. You can see in the picture the product streams in yellow color that are surrounded by steam in red color. Although we are not showing that in the picture, below the distribution nozzle, we can install a spray ball so the air can be removed during the production. And of course, we can utilize the same spray ball to CIP the tank. The product temperature would be precisely controlled by means of pressure. And we can also highlight that the heating rate within the tank would be extremely quick. We are talking about around 600 degrees per second. It is extremely quick, the heating. The delta T also inside the vessel is actually very tight, so we can guarantee that the product is not thermally stressed. The heating is very gentle, so you get in that way a superior product quality with minimum organoleptic changes. Besides, as you can see on the lower part of the vessel, on the conical shape, we've got a cooling jacket, and thanks to that cooling jacket, we could eliminate the foaming, and also it would help to reduce the fouling because it would be creating some sort of the condensate layer where the product during the fall would slip and will not foul up. On the utility consumptions and the operational efficiency part, we can actually install a high definition camera inside of the vessel. And by doing that, it would allow us to have real-time information on the performance within the infusion vessel, so we can monitor the falling rate. So this visual input would allow us to perform CIP when it's really needed. Actually, these days where you've got the operators sitting in the control room, they can easily have a look at the camera, realize what's happening within the vessel, and they can decide if they have to switch from production into CIP mode, or if they can just perform an intermediate aseptic cleaning to continue with the production. Then we have the NAC, which is what we call the non-aseptic cooler, which is a tubular heat exchanger that we are using for cooling of the circulated water to about 95 degrees during the pressurization phase. So we can recover up to 2/3 during this pressurization phase. And just to give you an idea about the numbers, on the heating load, you could be saving up to 563 kilowatts, and that could be for a flow rate of 40,000 liters an hour in your UHT line. So if you add all of those savings during a year, you realize that you're saving a good amount of energy. So actually the payback time is fairly quick. And obviously you can benefit from those energy savings during the complete life cycle of your UHT plant. Within the aim to reduce the total cost of ownership, to reduce as much as possible the OPEX, we can also offer the top condensers or recovery condensers, where we could be recovering up to 12% from the condensated steam in its way out from the vacuum vessel. So as you can see in the drawing, on the vapor duct, we can recover that vapor and reuse it in our UHT plant. So on a typical thermal profile for an infusion plant, where we could be, let's say, easily reusing this energy to do the preheating in the multi-section plate heat exchanger. So for example, we could be doing the thermal jump on the preheating in the plate heat exchanger from 4 to 78 degrees, just with the energy that we are recovering from the vacuum vessel. We can also insulate the vessels, so we can do that for both the infusion and the vacuum vessels. So essentially, we would be installing some mineral bull insulation with a stainless steel cover to save on that energy and avoiding the heat loss in those vessels. Also, we can save some energy if we decide to go with our hibernation mode during the waiting time. So after the CIP and the sterilization, you are typically running with water to maintain sterility. And with the hibernation mode, what you can do is that you can set the system at a 50%. So that would be like a 50% saving on the utilities. That means that you would be saving on steam, on water, on ice water. And that is something that we can easily integrate in our automation package. Here we present our latest MPD to reduce fouling and to increase the running times. We are calling this the APB seamless infusion vessel, and that could help you to increase the efficiency and the sustainability, as it is minimizing the fouling, and in that way, it is extending the running times. The APV seamless infusion vessel prevents from fouling in two ways. There is no sealing gasket between the vessel bottom and also and the pump housing for to have fouling building up, and also the second factor is that it has a better water cooling on the pump casing and the impeller. So in that way, we can reduce the temperature in that connection area. So essentially, you get increased uptime, and therefore you are saving on the CIP because you need to run less CIP cycles. And as a consequence, you are reducing the overall consumption of water, on chemicals, and energy. We have two innovation or development centers where you can test your products. One is located in Dubai, in the Emirates, that we set in close collaboration with the filling company SAG Combibloc some years ago. And we've got another one in Silkeborg in Denmark. So especially for plant-based applications, we can do many different trials with our technicians in both of our innovation centers because we've got a lot of experience on the field. We have pilot plants essentially where you can try your new recipes. And also we've got the possibility to offer you some pilot plants that you can rent, so you can do your own trials in your facilities. And of course, we can sell to you pilot plants. We can tailor-made to whatever needs you might have, so we can really customize the pilot plans for you. And we also have performance agreements. So these agreements are structured to ensure that our technology, that our plants are consistently meeting the performance expectations that you have. So by entering in a performance agreement with SPX Flow, you can benefit from agreed performance metrics, also maintenance and support from our field engineers during program shutdowns. You can also get remote monitoring of KPIs to track performance against targets. We can offer also troubleshooting. We can set specific trainings for your technicians. We can plan on delivering the needed spare parts that you might need, and also we can organize all sort of the different audits from our process engineers to improve your lines. So as you might be aware, our team is sharing this full series of different webinars, representing how our company SPX Flow is capable to support you during every step of the process. So in the communications materials, you should be able to find the links to past events, and also you've got the ability to register for future webinars that might be interesting for you. In the next sessions, we'll be talking about membranes, also about CIP, and also about plant-based fermented products. So this is the end of the presentation, and we will now begin our questions and answer session. So essentially, when we finish the webinar, all of the participants will be getting a copy of this presentation and also a brief survey. So I really encourage you to complete the survey because that would help us to better understand the value of the content that we were sharing today. Okay, so let's have a look at your questions. All right, So we can move now to the Q&A session, and I can see that we've got several questions. There is a question that says, if compared with the fouling rate, what is the difference between plant UHT treatment and white milk? Right. So essentially, the fouling rate, I would say that depend heavily on the type of ingredients and the type of plant-based that you are using. So the total effect of the fouling and hence the running time, which is I think it is the actual part where you are interested the most, would depend on the actual products. Just to give you an example, with oats and soya, we can actually have longer running times. We can do typically in our infusion systems up to 40 hours. Typically what you do is that you work for 20 hours and then you do an intermediate CIP, and then you can run for like another 20 hours. But then you've got other plant-based products, like for example, almond, which is trickier, and then the expected running time that you can achieve is much shorter, in the range of like 10 to 12 hours. And the comparison with white milk, if we take, again, as an example, a UHT plant based on infusion technology, that would be around 30 hours, with like 15 hours production time, intermediate CIP, and another 15 hours. So you can see that it's not far away between a product like oats or soya and white milk in an infusion system. Then we've got other questions. We've got here, what is the difference regarding shelf life between a pasteurized product, ESL product, and UHT treated product? So essentially, the shelf life would depend a lot on the raw material quality that you are working with. But just to give you some indication, like a rough idea, you can consider around like a week for a traditional pasteurized product. The typical one that you are running at 72 degrees for 15 seconds in the case of, milk, but still you have to preserve it in the fridge at 4 degrees. If you are looking at ESL product, we can reach up to 45 days if we preserve it at 10 degrees in the fridge. That is actually what we can achieve with our infusion plus technology. And then with a UHT treated product, we can reach up to like a year or something like that. Once again, it will depend heavily on the raw quality of the material that you are using. The good thing, obviously, about this UHT treated product is that you don't need the fridge. You can do the storage and the distribution at ambient temperature. Then we've got some more questions. What is the best technology if I'm aiming to get a high quality UHT treated plant-based drink? Right, so the best technology to get a high quality, a premium quality product, that would be the infusion system, and that's why I based the vast majority of the presentation on this technology. And the reason for that is that you will be getting the best in terms of nutritional value and also in terms of organoleptic features. In terms of the nutritional value and the organoleptic features, we have to consider the delta T, which is in between the steam temperature and the product outlet temperature is very tight on the infusion vessel. So we are being very gentle to the process. So there is no that thermal stress that you can get with other technologies like the injection system or tubulars or plates. There's also the concept in the industry of the C star value, the chemical damage. So the best results in terms of chemical damage are obtained in the infusion system, then in the injection, and then on tubulars and plates. So then we've got here another question regarding what is the basic model of pilot plan that we can offer. So the basic model would be tubular heat exchanger, but in that model you can add actually all of the technologies that we've got at industrial level: infusion, injection, plates, scrapes. So it will depend on the type of products that you are planning to run. The flow rate typically is 100 to 150 liters, but we can really customize to whatever flow rate you need: 300, 500 kilograms an hour. And obviously, on that customization process, we can include things like a balance tank, the aerator, different holding times, even like a backing box filler. So we can really design it to whatever preference you've got. Okay, and keeping an eye on the time, and I can see that it's 1 minute past. So unfortunately, we have to finish the webinar here. If you've got some other queries, feel free to reach out. And yeah, I can only say thanks a lot for joining us today. And yeah, you have an excellent day and take care. Cheers. Bye-bye.